Hello, this is Ms. DB, and in this video we're going to review how to do some of the problems on the Chapter 5, Section 6 worksheet. So first read over 340 to 342 to learn about the Hinge theorem and the other theorems and properties in this section. So if we look at this gate here, the wider that you open the gate, the larger the angle where the gate is attached to the post, where the hinge will be. So if CB is long, like in this one, when the gates open really wide, then angle A is also going to be really big. And if the angle is smaller, then the side is shorter. That's really what CB, or what the hinge theorem is telling us. So we have the hinge theorem that says that if measure of angle A is greater than angle D, then the side opposite will also be longer. The converse of the hinge theorem is also true. That tells us if a side, like side GH, is greater than side KL, then the angles opposite them will also have the same relationship. Now this only works if you have two congruent sides of one triangle congruent to the other sides, and we're talking about the included angle between those two congruent sides. So it only works in that kind of a SAS relationship. All right, so in number 1, we have that side ST is congruent to side WX and side SV is congruent to side WY, because those two are marked 11, these two are marked 10. So we're able to try to use the hinge theorem. So we are supposed to compare the length of side TV with the length of side XY. And we can do that by looking at the angles opposite. So angle S is 81 degrees, angle W is 88 degrees. Therefore, angle S is less than angle W. So we can then also say that the length of TV will be less than the length of XY. In number 2, you'll first make sure you can use the hinge theorem by looking for that corresponding sides are congruent. For example, FG and LM are both marked 5. GH and LK are both marked 7. So then you can compare angle G and angle L because the sides opposite them, FH and KM, have measurements, so you can decide which one is bigger than which one, and then the angles will go the same way. Now, if you have two triangles connected to each other, you have to remember how to name your angle measures. And we've talked about this a lot since Chapter 1, Section 1 probably. So when they ask us to find the measure of angle ACD, you start at A, then you go to C, and then you go to D. We're talking about this angle right here. This angle right here. How do we find that measure? Well, we know that it is a linear pair with this angle BCA, which is marked 100 degrees. So together they add up to 180 because they're a straight line. So I know that this angle is 80 degrees. I need to know that because I have to use that to answer the rest of the question. So if this is 80, now we're going to compare side AB, which is this length here, and the length of side AD, which is this length. So now we can look at what angles are opposite those sides. So opposite side AB is this angle, angle ACB. And opposite the side AD is this angle that we just found the measure of, which is measure of angle ACD. So then you'll be able to compare after that. All right, let's look at this one. We want to compare the measure of angle FHE. Well, where is that angle? If you don't know where that angle is, you're not going to be able to answer this question. So you start with F, then go to H, and then go to E. Trace that out, and you can see that the middle part, that's the angle we're talking about. My pen won't work, but we can see that it's right there. I'm going to insert a mark there. I'm talking about this angle down here. And I'm also going to compare that with measure of angle HFG. So here's H, here's F, here's G. The middle one is the vertex that we are looking for. That's the vertex of the angle we're talking about. So we're talking about this angle up here. I'm just putting an X up there so we can see what angles we're dealing with. So those are the two angles we're comparing. So decide which one is bigger than which one, or which one is less than which one, by the sides that they are opposite. So FHE is opposite EF, which is 24, and the measure of angle HFG, which is this angle, is opposite a side that is 28. All right, next we're going to find a range of values for a missing angle or side measurement. So let's look at, we're going to use the Hinge theorem to do this. There's a few steps to do though. All right, so let's look at this with a problem. Number 5, find a range of values for x. So step 1 says compare the side lengths in the triangles. Now, I know that this side is congruent to this side. I know that this side is congruent to this side. I know that those are true because of how many tick marks are on those side lengths. So I could write that those sides are congruent, but there's no letters on this, so that would be a little difficult. So I'm just going to focus on the sides that are not given to me, which is the 2x plus 4 and the 18. So which one is smaller than which one? I have to use the Hinge theorem to find out. 2x plus 4 is opposite 46. 18 is opposite 51. 46 is less than 51, so therefore 2x plus 4 is going to be less than 18, the other side length. Now you have to solve that to find x. So you're going to subtract 4 from both sides. I'm going to rewrite it down here so it works a little better since my pen tool stopped. And then I will subtract 4 from both sides. And then I will have 2x is less than 14, and then we will divide both sides by 2 to get x is less than 7. So we found an inequality for x. X is less than 7. Now we continue on because we have to make sure that our measures are going to be possible for a triangle. So 2x plus 4, we know that it has to be less than 18. We also know that this has to be greater than 0. Because a side of a triangle cannot be 0 or less than 0, or you won't even have a triangle. So I write that 2x plus 4 has to be greater than 0, and I simplify this. So I simplify this by I'm just going to solve this inequality. I will subtract 4 from both sides, and I get 2x is greater than negative 4, and then I divide both sides by 2 to get that x is greater than negative 4 divided by 2 would be negative 2. And x is greater than negative 2 is the same as negative 2 is less than x, because I could write that either way. So negative 2 is less than x. That means that my value for x for this triangle here has to be between the lower and the greater range that I just found. So the lowest that I found, x has to be greater than negative 2, or negative 2 is less than x. That goes in this part of my combined inequality. And it also has to be, x has to be less than 7. So that is the greatest it can be, so that goes on this side. So you're going to do the same thing to solve number 6 and follow those steps that we just did, and for number 7 and for number 8. So finish that up and find the range of values that x can be. Don't forget that it has to have a lower and an upper. Number 9 is just asking you to look at these two pictures. This is a backhoe, and you can see that the backhoe can have a small angle when the bucket is closer to the cab, or it can have a greater angle when the operator pushes it out. So you're going to answer in which position is the distance from the cab to the bucket greater, which is this dotted line down here, and explain your answer. All right, and then this problem here has to do with this figure. There's some problems to answer to put less than, greater than, or possibly equal. So be very careful when looking for these angles. Remember that QRP, angle QRP, you start at Q, and then you go to R, and then you go to P. So that's talking about this angle. I'm going to put a little X there again. Oh, I'll just put a little circle there. That's talking about this angle right here. So you're comparing QRP with the measure of angle SRP. So SRP is down here, S to R to P. So that angle is this angle. We're comparing it to this one. So I turn that one orange. So you're comparing the blue angle to the orange angle. And you can tell if it's greater or less than or equal by the length of the side that it is opposite, using the Hinge theorem. And then there's some extra credit questions at the end. Don't forget to answer question 15 first. I would draw this. And then in the extra credit, you would go to this link, which takes you to an optional interactivity from your textbook. And then after you do that, you'd be ready to answer these questions below. And it's not that complicated, so you might want to try it. It's just that we're not going to take the time to learn a whole nother part to this lesson. So there you go. If you have any trouble with this, let me know, and have a wonderful day.